Greetings everyone, Sergey Metelsky here from BlenderRust.com, and today I am going to show you how to create this fully procedural, extremely flexible, easy to build countdown with Blender and animation nodes. And today, jumping on the hype train, we are going to use Blender 2.8 and animation nodes 2.1.3. So as I said, this rig is extremely fast. No need to bake anything, no need to wait for it to, calculate each frame. It's easily customizable. As you can see, you can change this number, wake spread, digit height, wake height, and these are only parameters I exposed through animation nodes. If you want to, you can move this whole thing around, scale it, do pretty much anything with it. Change instance shape, you can make it a cylinder or cubes or whatever, any type of object. And it's not even necessary to be a number, a digit. You can plug in a text here and it works just fine, as you can see here. And the best part of it is that this rig is extremely simple. That's it. Like 25 nodes, no subprograms, no elaborate math, no need to program anything. This here, what you see, is all you need to make it work, actually. And first, as always, I'm going to break down a little bit essential steps you have to perform. There's 3 steps. First step is to generate an actual number geometry, which will change every second or given period of time. Then we're going to generate, let me show it to you. Then we're going to generate a grid and deform it with a number of modifiers. And finally, we're going to set up a shader. I'm going to show it to you in a second. Shader editor. That responds to object position and changes its color accordingly. Okay, let's start with new file. Let's delete everything. Let's expand our animation nodes tree. Create a new tree. I'm going to call it main, although it'll be the only tree we're going to use. Okay, so first thing first. Now, to generate a number, we need to turn frames in Blender into seconds. And that's really easy to do. We just need a time info node here. We need current frame and frame rate. That's really simple. We're just dividing our current frame by frame rate, which is by default, let's make it 25. Okay. Divide, and that way we have a float value right here. So 25th frame gives us 1 second. Okay, but we need an integer number, so we have to add another math operation, which is floor. So we're getting rid of decimate values and we get an integer whole number. So as you can see now, every 25 frames gives us a second counter. And now to make it an actual countdown, we just need our, like a starting value, which is integer. That'll be 10. And we need to simply, math. Subtract our current time from our initial time. And that way, once again, as you'd expect, we have our countdown. Now, we just convert it. Control A, convert this integer value to text and fit it to a text object, which we have to create first. Now create text. Okay, we're going to select nice bold and Gothic font, something like this one. Set alignment to center. Increase size a bit, like this. And we're going to call it something like countdown font. And then text, object output. Set it right here as our output object, and feed the text right here. Press this little button here. And here we have it, actual geometry for our countdown. Now, since we're going to use a shrink wrap modifier on our grid geometry, we need an actual polygon geometry because shrink wrap doesn't support font or curve objects. So what we do is we get mesh input from our text object. Check this. And fit it right back to another polygon object. Hit plus to create an actual object, and we're going to call it countdown mesh. So we know this is a font object and this is mesh object, and these are actually giving us visually same result, but I'm going to hide font, but this is a mesh geometry now. Okay, so we're going to hide both of them from render, and our countdown mesh, we are going to display it as a bounce. So we know there's an actual geometry for our digit, but we don't need to render it or display it. Okay, so first step of our setup is over. See, it's really fast and simple. Okay, now to the second part, to generating actual grid of hexagons. First off, we need to create an instance, an actual geometry for our hexagon, and for this we're going to create a circle with 6 vertices, and voila, we have our hexagon filled as n-gon. Let me just show it a bit better, something like 1.5, doesn't matter. And yeah, throw some modifiers on it. So first of all, we need to make it, we need to set a solidify modifier so it have some height, and a bevel modifier to make it look some more organic. Let me change our shading to matte cap. Yeah, that'll do. Add some divisions here, profile to 1.6, you know, just a matter of taste, and shade it smooth. Right click in Blender 2.8, right click and shade smooth. Now we need to, we're going to set up our shader later, but for now I'm just going to create a material which is going to be, which I'm going to call block. Now we'll leave it as is right now. Maybe, okay, up a bit. Okay, so this is going to be this, I'm going to call this hexagon, okay. And yeah, this object is now, we don't need to see it. Now create you know, any object you want, let it be plain. Go to edit mode, and with all the vertices selected, hit Alt M or right click in vertices mode, right click, merge vertices, add center. So we need a singular vertex here, and we in our actual grid object. And our grid object will be just an array of vertices, and then we're going to assign a doubly object, which is now called instance, for each vertex. You'll see it in a minute, okay? Just stick with me. Go to object mode, now modifiers, and add, we need 3 array modifiers. Oh yeah, totally forgot. We're going to parent our hexagon to this plane, and now we're going to enable instancing, which is in Blender 2.79b. Just want to remind you, called doubly objects or duplication. So we set it to verts, and for each vertex, now we have only one vertex. For each vertex, it's going to create an instance of its child. Okay, so in our case, this is our hexagon. And render instancer, doesn't matter actually. And now we're gonna start to drop in some modifiers on it. So we're going to uncheck relative offset since our object has no actual thickness. And we're gonna enable constant offset. So first, array modifier will offset our hexagon to actually form a minimal cluster. We don't need we don't need a super precision here, so we're gonna do it by eye like this. Okay, now I prefer to name my modifiers to for the sake of convenience. Okay, I'm gonna call it hexagon cluster. Now next modifier, once again constant offset, and we're gonna shift it by X value. And now increasing number of instances or count parameter, we can already see we have our grid. Okay, let's make it 40. So this is going to be our X array, and the last one modifier for our Y value, like this, you know, just a notch. And yeah, here we have our grid. Yeah, that'll do. Okay, so if we put a displace modifier here, for example, and set it to Z and assign some texture, such as let's say clouds, we can see, okay, depth to 1, size to something like, I don't know, 6. Let's go back to straight. We can see that by offsetting vertices of our grid, we're actually offsetting our instances, while the shape of our instance remain intact. Okay, so that's exactly what we want. Okay, next step, I'm gonna delete this displace for now. Next step, we're gonna shrink wrap our vertices to countdown mesh object. So shrink wrap, target countdown mesh, and you can see all the vertices are now shrink to geometry of our countdown mesh, but we need to project them. So we switch our shrink wrap to project mode. We set our offset for now for like 1 to see what it does better. And we switch axis to Z. And now we need to move our countdown mesh just a bit. Oh, we need to scale it first. And we need to move it slightly below our actual vertices of our grid mesh. So if we look at it from this perspective, you can see vertices slightly above geometry of our countdown mesh. Okay, and switch back to solid view. And you can see it's already interactive. You know, you can play around with it until you get the proper result. So yeah, starting to shape it up. And yeah, now we need to animate actual, you know, rising of these vertices. So we get our nice animation each second. So for this, we're going to directly affect offset parameter of our shrink wrap modifier via animation nodes. For this, we need to have a repeated value, some repeated value each second. Okay, so to get this, we're simply going to refer to our setup right here, and we are simply going to subtract this rounded value of our second from this float value. And what it does, you'll see in a minute. So we're going to subtract viewer. So by stripping down integer value from float value each second, maybe it's better to visualize it in 3D. So we're going to create a vector, combine Z, fit it right here, and make it green So, oh, super small. So as you can see, we got this. All right. And if we feed this value right into attribute output, our grid object, oh, it's play, let's call it grid. Grid object. If we fit it right here, so we copy data path from our offset parameter here and paste it right here and feed it right here. And you can see every second it rises up to 1 and then switch back to 0. And it's not very smooth, isn't it? Okay, so we need to interpolate this value. So it would reach its peak to a half of a given second, and then it slowly go back to 0 to the end of the second. Okay, so we are going to use a map range node. This is one of the most useful nodes. So we fit this value here. Don't change anything here. Just hit interpolate. And we're going to build interpolation from curve. And this is linear interpolation, so value won't change anyhow. And we're just going to draw this kind of ramp. I'm actually gonna modify it by hand and make a vector auto handle. Vector handle, yeah, vector handle here and vector handle here, so it's more smooth like. Okay, and fit it right here. And this way, once again, if we're gonna use our vector to simply visualize the effect of this node, let's call it green. Yeah. So now we have exactly what we want. Our sine-like motion. Now if we fit this into offset, yep, it works. The only problem is that it's too low. Like one Blender unit is not enough to actually give our nice offset. So we simply use this value as a multiplication factor for our height value. So number float. And this is going to be our actual offset height, which we are going to multiply by our factor. So I'm going to fit it right here. And now we can easily modify this value to get our desired offset height. It can be even negative, as you can see. So something like this. Okay. Now we need to set some, random movements for our grid, as you've seen in example. Okay, let's hide all of these, and just to make it a little more clear, I want to make some frame nodes, something like BAM. So we're going to call this text generator. This is going to be our offset, something meaningful. And now this value here, we're going to call it digit offset and show it in the viewport. All the nodes that I use to actually, control my rig, I prefer to give them some bright colors so I can visually distinguish them. Okay, so this one, let me blue and call it something like countdown start. Show it in viewport, and here in the right panel you can see them already, and you can manipulate them without actually expanding node editor here. Okay, now back to making this a little more organic. Let's add a displace modifier here, which we're gonna and set a new texture here. Let's call it clouds. And our clouds texture depth. To make it animated, we're going to use a control object in our modifier settings. So object, we're going to create a new object called axis, empty, and we're going to call it something like I don't know, cloud displace control. Oh, I totally forgot to create an actual rig, countdown rig, and to parent everything to it. Okay, so we can, manipulate whole rig easily. Okay, so our empty is countdown cloud displace control. Okay, now back to our grid object. I'm gonna call it cloud displace. Cloud displace. And now, to make it normal to Z, to make it animated, we just need to set some drivers for our cloud displace control. So we go back to transform, and we simply add a new driver to it. So I'm just going to write in frame times something like this. Enter. Hit enter, and now we need to set this object as a control object for our cloud displace. So now, as you can see, we have a pretty chaotic movements here. First of all, we need to scale our control object a bit, so we can actually see cloud texture here. And now, let me switch it to something, like this. Now you can see this movement starting to shape up. And maybe I'm going to copy this driver to X value as well. So we got this smooth wave-like motion. Now to generate these nice wakes every second, we're going to use same approach as with cloud displace, adding another displace modifier and using another texture and another control object. So first off, we're going to move it up above shrink wrap modifier, so it won't offset, already offsetted by a digit instances. So then we add another texture, go to texture settings and call it wake blend. And I'm going to select blend texture, switch it to quadratic sphere. I'm going to use color ramp. I'm going to put up something like this, intensity 0. And switch it to ease mode. And now, let me enable overlay. We're going to create another control object, another empty plane axis, parent it to our countdown mesh, so it'll be tied up to a actual digit position. It's not necessary, but I find it more convenient. When you move a digit, wake moves as well. So let's call it wake displace control. Switch back to our grid and modifiers, object, wake displace control. And let's increase strength a bit for now, just to see the difference. And let's start to scale. Oh yeah, we need to switch direction to Z. And by scaling the object, we can see our texture affecting our geometry. And as we move our digit, we can see it works fine. The only thing is that for some reason, oh yeah, I forgot to set mid-level to 0. Yeah, now it works perfectly fine. So, and you can see that by scaling this control object, we have this nice little wake effect. So we'll need to animate it procedurally via animation nodes. So let's hide it. We don't need it anymore, and set it straight. And we're gonna use same old value we got here with math node, our 0 to 1 range, to loop it with every second. So first off, we need to animate scale of our wake displacement control. So we're gonna find our kind of a final position for our wake, final width of our wake. We'll look at our scale. That'll be 60 by each axis, okay, and number, float, and 16. This is going to be our wake spread. Let's show it and show it in viewport. And now, sorry, add another math node, and we're simply going to multiply our wake spread value by 0,1 range every second. And then we're going to output it to scale value of our wake displace control object. So object, transform output, scale. We're going to turn this float into vector from value, wake displace control, and scale. And so now you can see works fine, but in order to you can see this, but you see it still kind of disappears at the end of each second, and we actually wanted to fade it gradually by the end of each second. So we're going to animate our displace strength parameter in the same manner. Actually, we're going to use, once again, another float value. Let me have some space here, okay. Which is going to be something like 1.3. Once again, we going to multiply it with the same value here, and object, actually let's just duplicate this node and Alt P, copy data path, paste it right here, displace strength, and plug it in here. Oh yeah, we need to reverse this value, so it goes from 1 to 0. So we're going to use our map range node and plug this value here, input minimum 0 to 1, and we just simply reverse these values from minimum 1 to maximum 0. And if we want to, we can interpolate this value with given interpolation, to ease values, or leave it as it is and plug it in here. So yeah, now we can adjust our wake spread. Works fine. Now we can play around with these values until you get a desired result, desired look. As you can see now, it's fully dynamic. You can move this whole thing around. And now to the final part, to shader. Okay, now we go back to our Hexagon instance. We're going to display it. We go to our shader editor, and this one is really, really simple. It takes a couple of minutes. Let's switch to our development look mode, and we're simply going to use our object's z-axis position to determine mix factor for color, object info, location, converter, separate XYZ like this. I'm going to see, and we're going to use our Z value here for mix factor and mix node. So Z, oh no, color factor, and you know, like blue as an example, and fit it right back to base color. And voila, right? I'm probably gonna switch it. You know, you can play around with it. You can control influence of objects' position by doing simple math operations with this Z value. So for example, if you want to maybe offset it or squeeze it by multiplying a bit, make it more, you know, contrast. All sort of things, actually. Or, you know, reverse. I'm happy with this one, actually. And now it's just only a matter of setting up your render. So let's go to rendered mode, and no, that development look, use scene lights, some HDR, add some sunlight with nice shadows, ambient occlusion, factor 3, some screen space reflections, blue if you want. You can do pretty much, you can customize this rig pretty much the way you like, exposing different parameters like number of copies for our array modifiers. And yeah, that's it. I hope you will find it useful in your personal projects. I really want to hear from you guys if you want to see more tutorials on you know, like basic concepts of visual scripting, or maybe you want to see more complex tutorials to finish results, like a finished motion graphic job from A to Z, from blank scene to final render. Leave some feedback, just let me know what you want to see. Like, subscribe, and visit my website, blenderust.com. And yeah, thanks for watching. Until next time.